Hello and welcome to this week's edition of Temple Tech Talk. I'm your host, Tom Martinez. Continuing from last week's subject of the rapid growth of the Internet, today we'll be talking about a big solution to a bigger problem. We have a special guest with us today, Temple alumni and Cisco Team member AJ Harnack. He's going to talk to us about IPv6. Welcome, AJ.
Thank you, Tom. It's great to be back at Temple University.
So, about IPv6, the technology world sure does love its acronyms.
Yeah.
What is IPv6?
Well, IPv6 stands for Internet Protocol version 6, and it helps us directly address the issue of the overgrowth of the Internet. It's the replacement for IPv4, which is the current protocol in use. Both IPv4 and IPv6 are standards used by all network devices. They detail the ways that these devices are identified on the network. They provide a unique IP address for each device on a network, which is fundamental in the sending and receiving of data.
So it sounds like an IP address is something like a virtual street address for each computer on the network.
That's absolutely correct. Every house needs a unique address for it to receive the correct mail, and every network device needs a unique IP address in order for it to send and receive data properly.
Okay, so why the switch to IPv6 and what was wrong with IPv4?
Well, Tom, it's a simple problem of the overgrowth of the Internet. IPv4 uses 32 binary bits to determine a computer's IP address. It's a string of 32 ones or zeros, and with the natural limitations of this system, IPv4 can provide about 4.3 billion IP addresses. The problem is that we have 7 billion people on this planet, and it's true that not all the people on this planet need IP addresses, but most of the people in developed countries need more than one IP address. Many things need IP addresses these days: computers, cell phones, video game consoles, networked home theater equipment, even some cars need IP addresses. The sheer fact of the matter is, under IPv4, we're going to run out. We're going to run out soon. Experts predict that at the current rate of growth of the Internet, IPv4 addresses will run out sometime in 2012, so it's not far off.
So we've got to switch to IPv6 if we want to allow the Internet to continue to grow. That's very interesting, but how exactly will IPv6 fix this problem?
Well, remembering that IPv4 addresses are made up of strings of 32 binary bits, IPv6 addresses are made up of 128 binary bits. It creates a number of IP addresses so large that there's no definite English word for it. It's 34 with 37 zeros after it. That's a huge number, and it should keep the appetite for new IP addresses in check for the foreseeable future.
Well, that certainly sounds like a good thing. It sounds like we need to switch now. What's holding us back?
Well, we're talking major changes to the fundamental way the Internet works. And as we all know, the Internet is absolutely massive, spanning every continent of the globe, even with data being sent to satellites in orbit. Everything needs to change. Computer network interface cards need to be able to recognize and use IPv6 addresses. Both residential and commercial routers and switches need to work with them. Every computer, every device, every website will be affected by a switch to IPv6. Fortunately for us, the switch is already underway. Many new computers and devices are already IPv6 capable. It's just a matter of time before the entire network is switched over to IPv6, and we don't need to worry about running out of addresses.
Well, that sounds like a big solution to a bigger problem. Thank you, AJ, for stopping by.
My pleasure, Tom. I'll keep an internship open for you over at Cisco. After all, we are the human network.
Alright, well, that's all the time we have for today. Join us next week when we discuss how to turn your cat into a robot and planting artificial intelligence into politicians, because heaven knows they need all the help that they can get.